Great. All right. Well, thanks so much, Martha, for suggesting this topic. I'm fascinated, and really looking forward to hearing what you have to say. Thanks everybody for joining us.
Yeah, so this is a little bit of an introduction, and for those of you who just heard me, I thought I would do this in part because we're going to be hearing a lot about eclipses in the next few months, and so I thought it would be interesting to talk about them. So here is what you see when you see an eclipse of the sun. The sun goes dark, and then after a period of a few minutes, it brightens up again. And I wonder if some of you actually have seen an eclipse before. I didn't see the one in 2017, but I saw one in 1972 in New Brunswick. Okay, we don't need to watch that anymore. Here's what happens if you watch that same event through a telescope. What you're seeing is the moon, the disk of the moon, move in front of the disk of the sun, blocking it out. And then the moon moves past, and the sun becomes visible again. And the event takes place over the course of minutes, a long eclipse being 5 or 7 minutes of totality. There's a curious coincidence that causes this to be a very peculiar phenomenon here on the Earth. And it's a cosmic coincidence that the sun is 400 times bigger than the moon is in terms of its radius. But the moon is 400 times closer to the Earth than the sun is. So even though they're very different bodies, the sun is hot, the moon is not so hot. The moon orbits around the Earth and the moon orbit around the sun. But as viewed from the Earth, the sun and the moon have the same angular size in the sky. There's no reason for that. It just happens. That's the way it is. And that, in fact, is something that confused the ancients for a long time. What is the difference between the sun and the moon? We know the sun provides a lot more light than the moon does. We know that the sun, if you go out in the sun on a day like today and stand there, you feel the sunlight heating you up. You go out tonight, the moon will be out there, it won't make you feel hotter. But they happen to have the same angular extent in the sky. And as I said, that's just the way it is. It's a cosmic coincidence. So I bring up this topic because there are 2 eclipses. Oops, I got a mistake there. This should be October 14th, 2023. This is April 8th, 2024. So this is actually next week. There is an eclipse of the sun that is taking place that is not going to be passing over us. But the one next April, on April 8th, 2024, and I'll talk a little bit more about what we might see here in Ithaca, next April is going to be almost a complete total eclipse here in Ithaca. And if you drive 2/3 of the way up Lake Cayuga, it will be a total eclipse. So it'll be an exciting time. There'll probably also be a lot of traffic, and we just have to hope against the odds that on April 8th, 2024, it's actually clear here in Ithaca. And we know the probability of that is actually not all that good. So let's talk a little bit more about eclipses. So first, we have to remember what's happening. We have the Earth rotating on its axis. We have the moon orbiting around the Earth. And then the Earth-Moon system orbits around the sun. We also have to keep in mind that the sun is much more massive than the Earth, and the Earth is much more massive than the moon, actually about a factor of 4. And the Earth orbits the sun, The moon orbits the Earth, and that all happens because of gravity, and we understand how that works. Here's a little animation that just shows you what you have to keep in mind. The red ball is the sun, the blue one is the Earth, and then you see the gray one going around the Earth as the Earth goes around the sun. That's the moon. And another thing to keep in mind if we're trying to understand what we need to see over the course of years and months is that here we have the sun, here we have the Earth, here we have the moon. The moon is orbiting around the Earth at the same time that the Earth is orbiting around the sun. And they do that in the same sense, so that they're all moving in this direction around. As the Earth moves around the sun in this direction, so also the moon is moving in a similar direction. It could be moving the other way, but it's not. And so another thing we have to keep in mind in looking at the geometry, if here we have the sun and here's the Earth and the moon, is which side of the Earth is facing the sun. That is when we have daylight. So even since the Earth is rotating on its axis, this side, of course, is facing the sun, and so the sun is up. In this case, we have the moon on the opposite side. This is the nighttime. In this particular configuration, the moon is full because its entire disk is illuminated by the sun, and we see it at night. It rises roughly at sunset, and it sets roughly at sunrise. And of course, we know that there are the phases of the moon going from the new moon to the first quarter, to the full moon, to the third quarter, to back to the new moon again. That's what happens over the course of a lunar month. And we can understand how that works and why there's a correlation between the rising and the setting times of the moon and the phases of the moon. If we just have this simple geometric picture where we have the sun over here, of course, the picture is much smaller than it really is. The distances are really very big, with the sun being 400 times further away from the Earth than the moon is. Keep that in mind. This is a compressed cartoon, and the Earth is turning around. So noon is when the sun, we're looking straight at the sun, and midnight is when we on our side of the Earth are looking opposite the sun. And so we expect there to be a correlation between the rising and setting time of the moon at its different phases. The new moon rises, we see it for the first time at 6 a.m. The sun is directly overhead at noon, and then the sun sets at around 6 p.m. At full moon, the moon rises at about 6 p.m. It's directly overhead at midnight, and then it sets at around 6 a.m. And so we understand how this works. And I'm going to point out that so did the ancient Greeks. They understood what was happening in the solar system, in part because they were trying to explain this correlation between the rising and setting times and the phases. It's just geometry. But there are a couple of tricks that we have to keep in mind. And that is, in this picture that I've shown you here, the moon's orbit around the Earth is circular, but that's not quite exactly true. If you look very carefully at this diagram, you'll see that the moon is sometimes a little bit further away and sometimes a little closer to the Earth than if the orbit were completely circular. It's not. It's a little bit elliptical. And that leads us to the interesting phenomenon that we had last week. Maybe you heard last week we had a supermoon. A supermoon is when the moon is a little closer to the Earth when it is full than the other times when it's further away. We have what we call a micromoon. If the Earth is closer to the moon at what we call perigee, then the moon appears a little bigger in the sky. And if we have a full moon at what we call apogee, then the moon appears a little smaller than average. And so we end up with what we call supermoons and micromoons. And so here are just two examples from pictures taken in 2010. We actually can measure the difference. If we can measure the difference in the size of the moon, then we know where perigee and apogee are. And that was also noticed by the ancients, by some of the ancients who were able to make accurate maps. They at least noticed that sometimes the moon is bigger and brighter, and at other times it's a little fainter and further away. So now let's talk about eclipses and what happens during an eclipse. Eclipses of the moon occur when the moon passes through the shadow of the earth. In other words, the sun's over here. Here we have the earth. The earth casts a shadow. If the moon happens to pass through the shadow, then the moon partly disappears or completely disappears. And we don't see it. It becomes darker. Now, that's another difference between the sun and the moon is that the sun gives off its own light. It's hot. It's a glowing ball of plasma. It gives off its own light. What we see when we're looking at the moon is we're seeing the reflected sunlight off the surface of the moon. So that's another fundamental difference between the sun and the moon. The sun is hot and glows. The earth is like a big mirror which reflects sunlight. And so if the moon moves through the earth's shadow, then we don't see the reflected sunlight and we get what we call a lunar eclipse. The purpose of today's talk is to not really talk about lunar eclipses, but rather to talk about solar eclipses. And solar eclipses occur when the moon blocks out this bright light from the sun behind it, and the moon casts a shadow on the surface of the earth over a small area on the surface of the earth. And the sun's light, as seen here, is completely blocked out. So what you're seeing in the black here is the moon. The moon doesn't give off light that we can see, so it appears black. In order for that to happen, the sun has to be over here. The bright side of the moon is facing away from us. So this must happen at new moon. So here we have the example. Now the sun's over on this side. This is an actual little diagram. A lot of the diagrams that I'm going to show you today come from websites that talk about the 2017 eclipse, which was visible in other parts of the country. Maybe some of you saw it. Here we have the moon. Again, the moon phase for this to occur, a solar eclipse, is when the moon as viewed from the earth is new, because the sunlit side is facing away from us. And again, here's the moon's shadow falls on the surface of the earth, and we get over a small range on the surface of the earth, a few hundred miles across, a total eclipse. So this happened in 2017, and this is what is also going to happen next week and also in April. But we have to talk about the difference between what's happening next week and in April. There are actually three kinds of total eclipses. One is the partial eclipse, where the eclipse doesn't completely happen. Either you're not quite in the center of the moon's shadow, or the moon doesn't fully block out the sun. And then two kinds which are both total, in the sense that the moon passes directly and completely in front of the sun, but have to do with the fact that the Earth's orbit, like the moon's orbit around the Earth, is not completely circular. So sometimes the moon is closer to the sun, and sometimes it's further away. when the moon is a little further away, then its angular size is smaller than average. And so the sunlight isn't completely blocked out. And we get what we call an annular eclipse. That's what's going to happen next week. Next April, the moon will be a little bit closer to the Earth than average. So its angular size is a little bit bigger. And so it's going to completely block out the sunlight. And we will see a total eclipse. So again, we have the sun, the moon casts a shadow on the Earth, but the moon can move a little bit in its orbit further away from or closer to the Earth, and that allows us to get a total eclipse versus an annular eclipse. Now, if we just are thinking about this, we might say, why don't we get eclipses every month? Because we have full new moons every month. Why don't we get eclipses every month? And that has to do with the fact that the Earth is orbiting around the sun in a plane, but the moon's orbit around the Earth is tilted to that by only 5 degrees, but that's enough to make the shadow of the moon miss the Earth most of the time, on most months. If they were all perfectly lined up, then we'd get eclipses every month. But the fact that the moon's orbital plane is inclined by 5 degrees to the Earth's orbital plane means we don't. That doesn't happen. The Earth doesn't pass through the moon's shadow most of the time. So here we have some examples where the moon's shadow, because its orbit is tilted with respect to the Earth's orbital plane, the moon's shadow falls off the Earth to the north in this case. Sometimes it might fall south. This means we don't get eclipses every month. Here's a little animation that's supposed to show us that. So now the shadow is too high above the Earth. Sometimes it's too low. And then sometimes it's just right, and we get a solar eclipse. Here's another little animation. This is of the solar eclipse that occurred in 2017. It crossed into North America, passed across the center of the US, and you can see the shadow of totality is very small. The complete totality is just that little dot, and it sweeps moving very fast so that any location only has an eclipse that lasts a few minutes. The outer part, though, you see where it gets partly dark, that's where you see a partial solar eclipse. Another interesting thing that I'll just mention a little bit is that, in fact, there's a repetition of eclipses at individual locations on the Earth, which is called a Saros cycle. And the configuration of an eclipse at a particular location reoccurs with a periodicity of about 18 years. And that periodicity, which is called the Saros cycle, comes about because there are different things going on. The moon is going around the Earth. So we go from full moon to full moon. That's called the synodic month. And that's one way of telling time. But remember that during that month, the Earth has also moved in its orbit. Then we also talked about the fact that the moon's orbit around the Earth isn't exactly circular. So another time scale we have to think about is called the anomalistic month, and that's the time from perigee to perigee, the time between when the Earth is and moon distance is smallest to the next time the Earth-moon distance is smallest. And then we have another time scale having to do with the orbit of the moon around the Earth, and that's called the Draconian month. And remember, we talked about the fact that the moon's orbit is inclined with respect to the Earth's orbit. That's from the time that the orbits intersect to the next time they intersect. And these three periodicities, this one tells you whether or not the shadow is going to fall on the Earth. This one tells you about whether you're going to see an annular eclipse or a total eclipse. And this one tells you about whether you're going to, what configuration, what phase of the moon you're in. Those three combine to make up a periodicity of this 18 years. This repetition was actually realized in 700 BC. And I think that's another thing we have to think about in terms of our culture and our nature. The ancients paid a whole lot of attention to the motions of the sun in the sky, the moon in the sky, and the different periods that came about. They were aware of eclipses. They knew, some of them actually tried to put all the information together to figure out what could be causing this. And that actually led them to understand the heliocentric model, which then Western civilization decided to forget for 1,500 years. Here's a little demonstration that just shows these repeating cycles. And this I want to bring up because we now know how to predict eclipses very, very precisely. And we can tell exactly what part of the Earth is going to see an eclipse with 1,000 years in advance, as long as we keep our time system the same. But we can see that these eclipses will recur in different locations. And what's interesting about our current period is that there was the eclipse in 2017 that was a total that crossed North America. There's an annular eclipse that's occurring next week that will cross parts of North America. And then there'll be the one in April next year. And then there won't be another total solar eclipse visible in North America until 2045. And so I think those of us who are on this call today should probably pay attention to the ones that are happening this year. So here's the 2017 eclipse. Here was its path. Its greatest eclipse duration was only 2 minutes and 40 seconds. And it did pass across the United States. And I wonder if any of you actually traveled somewhere to see it, because it wasn't very visible here in Ithaca. Anybody go to see it? I don't see that anybody.
I think I was in Washington, D.C. then. I mean, I saw an eclipse sometime and I was at a meeting. Could you have seen it in Washington partially?
You wouldn't have seen it as a total eclipse.
No, we didn't see it as
You
total.
might have seen it as a partial
I
eclipse.
saw it as partial. Yeah, it was a big American Chemical Society meeting and everybody came out of the buildings.
Yeah,
and
everybody wanted to see whether
we all had
with
special classes.
Yeah, right. Exactly. Well, we have a better chance in April. Okay, so let's, I've just put this up because we can find out where we are if I move this forward. This little animation allows you to look at what phase the moon is at any time on any given day in the year. And so I've advanced us And I'll set it going. So this is the 17th of August. I want to go forward a little bit. So here we are today. Here's the moon as it appears tonight. And now if we let it go forward, you see that next week we go on to October 14th. We will be at new moon. So if we have a new moon, we can get a total eclipse. And so there is a solar eclipse that's going to occur next week on October 14th. Here's the path of the eclipse as the Earth rotates underneath, as the moon is moving across. It will not be total. It will be an annular eclipse because it's occurring when the moon is at apogee. It's further away from the Earth than average. And here in Ithaca, it will actually be a partial solar eclipse. It will be at maximum partial solar eclipse at 1:15 p.m. And it won't be terribly impressive, frankly. But it is taking place next week, and maybe it will be clear. So here are the times. The time from the beginning of the eclipse to the end of the eclipse. And what I mean by that is from the very first moment that the moon blocks out any sunlight to the time when the moon exits on the other side and the sun completely comes back, is about 2 hours and 28 minutes. And I see there is a note in the chat that Mary Helen saw the eclipse in Montana. That seems like that would be a good place to go.
It was good. It was not spectacular.
It got dark?
Yes, but not dark. And what is it? The corona, the area around
it
is fairly minimal. So my husband, who has been to saw one in Maine in the 60s, said it was nothing like that.
It
was,
it
very muted would be a term.
It depends on a whole bunch of different things, including the activity level of the sun, which is higher now than it was then.
Higher now than it was in 2017.
Yeah.
Okay. And can you go back and see what it was like in 1968?
I'm afraid you can't find any YouTube videos from 19.
Right. Okay.
I saw one in New Brunswick in 1972. I think if he saw it in New England in 1968, I'm not sure that was a total eclipse. Maybe it was.
So I may have the wrong date. It was in the 60s. It may not have been 68, but there was apparently one that's well known that he went up to see it in Maine.
Okay.
Wasn't 72.
Okay. Anyway, here's the path of the solar eclipse that's going to take place on April 8th, 2024. And it is going to be a total solar eclipse in which the sun is completely blocked out by the moon, because the moon is close enough to the Earth that the entire solar disk is blocked out. And so we can take a look. You can go to this website, which I have linked here, and you can see that we are almost in the path of totality. In fact, the northern end of Cayuga Lake is in the totality path. It would, if you travel closer to the center line, you would see a longer eclipse. Here's looking even closer again, even in Syracuse, they'll get more totality. Here in Ithaca, the sun will be 99% blocked by the moon. So I would say even in Ithaca, it will get pretty dark. But if anyone is interested, it would be possible to drive not very far away and see the total eclipse. But there are a couple of things to warn everyone about. First of all, a lot of other people are going to want to be in the totality path, so that what advice is that you get to wherever you're going in advance of the eclipse, and you plan to stay for a while after the eclipse is over. Because apparently during the 2017 eclipse, people would drive, as one might, to some random location within the totality, but people would go to nice places where they could have picnics, like parks or something like that. And then after it was over, everybody wanted to leave, and so the traffic jams were terrible. So you might keep that in mind. Another thing is that you also have to be prepared for the fact that this is upstate New York in April. And we all know that the weather in April in upstate New York isn't always perfect. And so maybe you get to see nothing. And the third thing is that in order to view an eclipse, you should not view it without special eyeglasses, which you can buy on Amazon at the moment. And so you might, if you're interested in viewing the eclipse, I suggest you find yourself some eclipse glasses. Make sure that they are NASA rated or something else that looks proper, and aren't just pieces of some kind of film, that they will actually block out the light so that if you're staring at the sun, you don't damage your eyes. But again, here's the information. 99% of the sun will be blocked. The actual duration of the total eclipse from Ithaca will be this 2 hours and 26 minutes. It will never be, but that's the length of time from the first moment part of the moon encroaches on the solar disk to when it completely leaves. There will be no maximum totality here in Ithaca, but it will be pretty close to maximum at 3:23 in the afternoon. So maybe we'll talk about this more closer to the time. Maybe some people, there'll be some events in Ithaca where people are observing the eclipse. Does anybody have any questions at the moment? Otherwise, I might talk a little bit more. Well, okay, I thought it might be interesting also to look. Oh, here's the path of annular solar eclipses. Oh, Jane has a question. Jane, go ahead.
Hi, Martha. This is Roger Segokin, actually.
Oh, hi.
Do other planets with moons have total eclipses, or are we just the luckiest ones in the solar system?
No, that's actually a great question. And in fact, yes, of course they have total eclipses. Jupiter, for example, I don't have the figure here. Maybe I'll talk about it sometime, what you might see from other planets. Jupiter has lots of moons, and they can cast shadows on the planet itself on occasion, and we can observe those shadows from our spacecraft. And so there are some famous pictures like that.
Wow.
It all depends on the relative size of the moon and how close the moon is to the planet. That will dictate how large an area. Remember, these solar eclipses occur only over a small region of the Earth at any time. But we see these when we look at other planets with our spacecraft. We can see the moons of them casting shadows. And that's essentially what it is. We on the Earth rotate through the shadow of the moon. We also see, just as an aside, and maybe I'll talk about this as weird phenomenon in the solar system, sometimes we see the planets moving directly across the surface of the sun. In other words, a planet moves directly in front of the sun. Again, all of the orbits aren't exactly lined up in the same plane. They have a tendency to be a little bit offset. So we don't see this all the time, but once in a while we see what we call a transit of, for example, a transit of Venus, when Venus moves exactly in front of the sun, and we can see pieces of the sun being blocked out by when they fall in the shadow of Venus as viewed from the Earth. What is really curious is that as viewed from the Earth, the moon and the sun subtend the same angular size in the sky. That really is a cosmic coincidence. So this just shows annular solar eclipses from 2001 to 2050. Again, we understand what's happening so much that people can make predictions of what is happening. And so here's the October 14th, 2023 eclipse. Again, it's an annular eclipse. We're up here, so it will be a partial, not very impressive eclipse from here. But if anybody happens to be in the American Southwest next week, maybe you'll get to see something more interesting. And here's the total eclipse for April 8th, 2024. It starts crossing Mexico and then runs up towards Canada in the eastern part. Okay, I thought it might be interesting to just point out that eclipses have been recorded over history for a very long time. And so I did a little sleuthing myself. Perhaps one of the earliest eclipses is believed to be contained or memorialized in a megalithic monument in the middle of Ireland. It's believed to be associated with a possible solar eclipse, which astronomers can trace back when there might have been a solar eclipse in that occurred in this County Meath in Ireland in 3340 before the current epoch, BCE. This actually was an article that appeared in the New York Times a few years ago. And what they see is a series of spiral-shaped and circular petroglyphs on this monument. And they trace it back to potentially representing something to do with this eclipse in 3340 BCE. That's just to show you where it is. If any of you ever go to Ireland, you can try and check that out. Another potential report of ancients viewing a solar eclipse are on what are called the Chinese oracle bones in China, where they recorded astronomical phenomenon on oxen shoulder blades and tortoise shells. And according to the scholars, the scribes said that the sun had been eaten. So again, giving the idea that what is being recorded here could have been a solar eclipse. what astronomers have been able to do is astronomers at JPL, the Jet Propulsion Laboratory in California, make very precise measurements of the Earth's rotation on its axis. They understand the exact shape of the moon's orbit around the sun and how the Earth is moving like a top. The Earth is spinning like a top and moves around a little bit. So the North Pole is slightly goes around with us every 26,000 years. And they come up with the fact that at this location in China, there must have been a bunch of solar eclipses in this period of about 1200 BCE. They use that because there are a succession of these bones. They use that to understand that the Earth's rotation must have slowed down a little bit in the past 3,200 years by piecing together these eclipses that might have occurred over different periods of time. I find that an amazing extrapolation, perhaps, of what we're able to deduce based on these inscribing marks, diagrams on these oracle bones. But that's what a team at JPL has concluded, that the Earth's rotation has slowed down by 47 thousandths of a second per day in the past 3,200 years. There are also lots of other mentions of eclipses in Christian texts. There are references to the fact that the moon turned to blood after Jesus's crucifixion. And we know that in a lunar eclipse, the sunlight isn't, the reflected sunlight isn't completely blocked off, but the moon gets dimmer and takes on a reddish hue. And so, in fact, this writing that the moon turned to blood can be narrowed down to being a possible coincidence with a lunar eclipse that occurred on Friday, April 3rd in the year 33. There is also a mention of a solar eclipse in the Quran before the birth of Muhammad, as well as on the day of his son Abraham passed. In Mesoamerica, there are lots of references to eclipses. The Maya seem to keep meticulous records, and they documented a number of eclipses. And they also made predictions about eclipses. And so there is one claim by Harvey and Victoria Bricker that the Mayans actually predicted the solar eclipse that took place over Mesoamerica in July 1991. So again, these are, I just bring this up because I think it's really interesting to note that solar eclipses were definitely paid attention to over the course of history, and that we should pay attention to them too, even though we know so much from our big telescopes like ALMA, JWST, and Hubble and everything else. We can identify with these dramatic events, which our predecessors thousands of years ago also paid attention to. Anyway, I think I'll stop there and see if anybody has any questions. And I'll just go back to the solar eclipse on April 8th, 2024. And it's going to be total, not very far away from us. All we have to do is hope that the weather is like today. And even if you don't feel like getting in your car and driving somewhere, it'll be 99% total here in Ithaca.
I'm putting it on the calendar now.
Okay.
Any questions? Any thoughts? Is it a date, everybody, for April 8th? Well, Martha, thank you so much. This
Yeah,
was
sure.
really great. I knew a lot of this, but I needed to be reminded for sure.
Well, I think it really is an amazing event, and
Yeah.
it's going to be something that's taking place here. And maybe we'll all be around in 2045, but
Right.
maybe we
I
should
don't
take
know.
advantage of 2024.
I hear you. All right. Thanks,
Okay.
everybody.
Well, thanks everybody.
Thanks, Martha.
Bye-bye.